Now, let me take you back to our it's actually there. To the business cycle. This is what we had. And we said this is the trend line. Okay. So this has been a little bit of finance in economics. Now we move to statistics in economics. Okay. Because you look within that budget summary. It says the forecast for 2014 is that inflation will be this much. In 2015, it will be this much. You know. So where are they getting those figures? Through statistics. You focus through statistics. So using statistics, you are able to come up with this line. Okay. To say what is the GDP in 2011, you know, in 2012, you know. But what will it be in 2013?
The average growth between 2011 and 2012.
You can use the average growth in 2011 and 2012 and use that as a way of forecasting. Or you can create a model, a statistics model, that once you put in the number of years, it takes into consideration the previous year's growth rate and then gives you a figure. Okay. Let me ask you something that relates to this last quarter that we are in, October, November, December. What normally happens to your cells? Cells within your organizations.
And then decrease over December.
They increase. But does that mean that your demand for your product has increased in general?
No.
Yes.
What is that? How can you explain that?
It's because people have a little bit more money to spend.
Bonuses.
Yeah.
So you
Depends on industry, you know.
Mm-hmm.
always compare
Yeah.
the figures of either last quarter or of December with the previous.
So this last quarter, which is October to December, and the previous quarter of September, and I say, look, this is what was there in September. This is what has happened to this quarter. Does it show that sales have increased? Is it a true reflection of the demand for the product there?
No.
Why not?
You need more data than 2 quarters.
It's more?
You need more data than just 2 quarters.
Okay. What else?
I think, for instance, we can compare the current or the current financial year quarter of maybe last quarter with the last quarter of the previous year, because we know that during December time, everybody is having money, in fact, to go and spend. So it makes perfect sense that we compare those, quarters, December to December, of different financial or of different years. So we cannot compare December and January. Obviously, we will not get the desired comparison requirements.
Yeah, that's basically true, because December now is affected by seasonal variation there. You know, the increase is not necessarily that people now demand your product. It's because of the season. There's an element of the season there. You know, it's the festive season. People want to go home. All right? So for us to see a true reflection of the demand, we have to either compare the last quarter and this year's quarter, or remove the seasonal component from this current quarter. Then we can compare it to the last quarter. So what are we doing there? We have deseasonalized the data. So then it enables us to compare this last quarter to the previous quarter. Okay. Guys, I'm not talking Greek here. You must see at least some response. Okay, let's refer to the study guide. Page 96. So one of the methods there to get a good trend is to use the moving average method. We are on page 96, right? The moving average method. So if you look, we've got information for 2011 for the whole 12 months. January to December. And we've got sales. You see that? The sales in December have increased from the sales in November. The sales in August are very low. But somebody can still argue that in September, others get their bonuses earlier, or their profit share or something. That's why sales have increased. So let us remove the seasonal component by using the moving average method. Okay. So the last table, what it then has, where it says time series Y and the periods. If it is, your moving average depends on what you have decided to use. You could use a 3 moving average, you could use a 5. A 5-centered moving average, you could use 2, you could use 8, depending on the size of your data that you have. So let's look at one that uses the 3-period moving average. So what do? You take your first 3 items, add them together. 7, 3, and 5 gives you 15.
Divide. Centered between the 3 numbers.
Yes, centered between the 3 numbers. That is the key thing. And then you get an average for those 3 numbers, which is 5. Then you take the next 3, leaving the first one. So it will be centered on 3, 5, and 9. The next one will be centered on 5, 9, 7. And then it continues. So what it does is that it eliminates the first variables and the last variables. But if you get sufficient information, it gives you averages that will eliminate the sharp ups and the sharp downs. So these ups and downs will not be there. Okay. You then have something that is showing a trend, much more smooth, as on page 97. You see how the original data is. It is in up and down. But the 3-period moving average is actually showing you a trend.
I have a question here.
Mm-hmm.
When you compare the data in February and March, you see there is 5 repeating itself twice.
In February and March.
Yeah. So there is 7 plus 3 plus 5, and then 3 plus 5 plus 9.
Yeah.
So what makes us believe that the element, the component of seasoning here for 5 is correct, or why?
Because remember, your sharps there are because you are having one variable. But now, the fact that you are mixing it with 2, it eliminates these spikes of up and down. It is like what we did with inflation, was it the other day? we had one price of a product that increased by 100%. And then we had the other price that increased by 40%. What did we say? It's an average within a basket. So it's the same principle of an average, except now that here in that basket you might have 20 items, but you don't center them that way. You actually use a percentage of income that is spent and the importance that the consumer places on each product. But here we are just averaging those three. So if you average 140, the average will be somewhere in between there. It will not be high, it will not be low, but it will smooth out. So what it does is that it will smooth out these and then show a general trend which is that you can work with. So it's giving you a direction. Okay. What has happened to the first variable is that we have, you see where it says centered, it is no longer there because it's now incorporated into the first three components. So you have 7, 3, and 5 that are now being centered and are giving you an average of 5. Right? Then you take the next three, which will start from 3, 5, and 9, an average of 5.6.
Okay.
And then the next one you take 5, 9, 7. So the fact that 5 now appears twice doesn't change the fact that it is being part of an average. So it's coming back again, it's there. The same with 9. But the fact that you are putting them together and averaging them eliminates these ups and downs. So you will see that within the last month, which is December, there is no value at the end because it's incorporated into the other two. Let's move together with numbers. So the first one is 735. The next one becomes 359. And then the next one becomes 597. The next one? 975. The next one? The next one? 912, 12, 4, 10. 4, 10, 13. Right? And then?
4, 10, 13.
So 13, 9, 10. Then uses the last variable. Okay. So you can now plot these original variables of 7, 3, 5, which then gives you this graph which is spiked up. Then you plot the graph with the 3 moving average. You see the second one, which is like a dotted one. You see the difference of what it does. If a graph is like this, sometimes when you plot the original variables and they are showing you this, sometimes it might not be easy to tell which direction this is moving. But when you center it and you have the 3 moving average, look at the dotted line. You can actually see what is happening here. Okay. So it's actually going up here. Do you see any difference?
Yep.
No.
Yep.
It does. It's much easier to see with the smoother line than with the one which is up and down. Okay. So that is one part. That is one part. You can then use these moving averages. The second part is to use regression analysis. Now, regression analysis will then give you an equation that you can then input and get this line. So you are estimating this line as an equation. It's regression analysis. Okay. Shall we take 30 and then do the regression analysis? Yeah. Let us see. We are still talking about our trend line. Before we went for lunch, we said you could either do the moving average, where you would choose whether you do a 3-centered moving average, 5-centered, depending on what you have chosen. Or you could do a regression equation. So you could use regression analysis to come up with an equation that would be able to estimate the data that you have. And then you can use that equation to focus on years, on the future years. So basically what you then do is you come up with an equation. Y is equal to A plus BX. So this becomes your independent variable. This becomes your dependent variable. So you will now need to find out the slopes of the coefficients to calculate the slope of A and the value of B. Okay. So let us take any 2 years. Let's take any 2 years. 2012. 2012. Let's use quarters, January to March, right? January to March, the first quarter. The second quarter is from April to June. Third, July, September. Fourth, October, December. Okay. So if we then say to you, what are we using? Demand. What has been the demand of bread in these periods?
78.
Let's just use arbitrary numbers. Any figures. You'd expect it to increase here. December. Or it doesn't change.
Yeah, so 70.
I'm talking about bread.
Bread. That's 13, 16.
16. Okay. And we go to 2013. Okay. Any figures there?
14, 9, 15.
15. Okay. Then we say October to December. Okay. What are we going to do? We need a value there. We need a value for an estimate for demand for the last quarter of 2018. As we are sitting now, which is the 27th, we want to know. We will have the actual figures at the end of this quarter. But we need some figures to work with. So what then do we do? We need to forecast using statistical tools to try and estimate what this figure would be, given the figures that we already have. So regression analysis allows us to do this. Okay. So like I said here, the first thing now here is to represent this in the form of an equation. Okay. So this is our demand for bread. So we change this and say On the other hand, we've got demand this side, and then we've got time this side. You see that? This is time. So this then would be represented by Y. This is the demand. This is what we are looking for. Then X becomes the time. So in this case, the first quarter will be assigned, because you cannot work statistically with months, but you can only work with numbers. So you change these into numbers and say 1 now represents quarter 1, January to March, 2 represents the second quarter, 3, 4, 5, 6, 7, 8 going down. But you've got information for these. You don't have for this one, which is what you're looking at. So if you're able to estimate a regression line that would statistically give you a relationship between this, what happens to Y over time, then you can use this to estimate what is happening there.
So the last line is what is time?
Yes, it's time. Okay. So I'm going to take the same figures. Okay. We've got 1, 2 to 7. Let me just tear this. It's giving me problems. Right. So let me have X and then Y. So I've got quarter 1, so you see from here that 1 is referring to January to March, right? 2 is referring to April to June of 2012. Okay? So what is the demand within that period? We've got 8, we've got 6, we've got 13, we've got 16, we've got 14, 9, 15. Okay.
Why aren't you putting number 8 there with the question?
Number 8, because we don't have a value.
Okay.
Yeah, we don't have
So
a
we're
value.
going to work it out.
We've got to work it out.
And what variable would that be? A or B?
It will now become, because it will now become number 8.
And would it, okay, carry on.
Okay. It will become number 8. So what we then do now is use regression analysis to be able, because what we are saying here is the best thing that will fit this as in regression analysis, because we are talking about a line. Say this demand is represented by a line. It might not be that particular line, but it is a trend line, right? In microeconomics, normally demand is like that. But we are just saying that this is represented by a trend line. So what we want to do is we want to estimate this trend line, this line. So in a business cycle like this, we are talking about this trend line. We want to estimate this trend line. Okay. So remember, a straight line would have an equation mathematically. Okay. For you to have that, mathematically this is an equation. So we're saying this will be represented by an equation of such a nature. Okay. Now this is gonna change my. Okay, it's fine. So what we then do now, we then use statistics as in page 100. So it now tells you how you will then, the formulas that you would use to get that particular equation. Okay? So now let's work together the figures that we have. So we'll need to find the total of x. What is the total of x? What is the total of y? Now the total of y statistically will be represented by the sigma notation. So this says the total. And what are we totaling? We are totaling x. And what is x? X are these numbers. So this says what is the total of x, what is the total of y. Okay. Can we work together? What is the total of x?
28.
28. The total of y?
70.
Sorry?
70.
81.
Huh?
81. Okay. Now what are we doing next? We are going to do the sum of x squared. Sorry. X squared and then xy. X squared. You are squaring that number. So you say 1 by 1. So you multiply the same number by itself. So if it's 2, it becomes 2 by 2. If it's 3, it becomes 3 by 3. So 1 by 1 gives you 1. Then 4. Here 9.
12.
16.
Oh, sorry.
25.
36,
36. 49.
64.
Okay. What's the total of sum of x squared? Total sum of x squared.
What is it?
140.
140. Okay. Now we do xy. So we multiply the value of x by the value of y. So the first one becomes 1 by 8. The second one becomes 2 by 6. The third one becomes 3 by 13. That gives you 39.
64.
64.
This is 12.
70. 54. 54.
6 by 9.
54.
105.
105.
Yeah, well,
Okay. The sum of xy.
352.
Says 352. Is that so?
yes.
Okay. Is that so?
Yes.
Now, how many observations do we have here? In terms of demand, we've got 7 numbers, right? Is that so?
Yes.
So-
352. How much did we get?
Yeah,
352.
352. Yeah.
Not 352.
So we say n is equal to 7. We've got 7 observations here, right? The 8th one is missing, which is October to December 2018, which is the one we're looking for. The ones we have, they are 7. Right, huh? Okay. Now we plug these into our formula for the values of B and A. Okay. Let me do this.
Let's stick them somewhere.
Sorry.
Let's stick them where it doesn't work.
Will they?
I can bring them.
Yeah,
Okay.
please.
Yeah, it's fine. So what's the sum of x?
It was 7, right?
28. the sum of y, the sum of xy.
X what? 52.
352. Then the sum of x
X
squared,
is 140.
140, and
You say equals 7.
7. Now you come and say, what is the formula for finding b? Okay. What is the formula for finding b? B is given by n
67
summation of xy
minus the sum
summation
of
of x sum
sum
of
of
y
divided by
n
n sum of x squared
sum of x squared
minus
minus sum of x all squared.
to the power of t.
Okay. So what we have, b is equal to n is 7, sum of xy 352 minus sum of x sum of y, that is 2881 over 7 140. Yeah.
Can you see that?
That's all. Now we solve with our calculators. 7 by 352 gives us 2464. 28 by 81. 2268. Divide by 2. What's the value of b? Are you getting that?
No. B I got 1.7.
You're getting what?
1.
1.67.
Answer is 1.
264.
I got no 0.7.
Yeah, me too.
Minus 1.
You get?
I got 196 over 280.
Okay, let's solve the top part first.
Yeah, so that 264 minus 2268 is 196.
It's 196. Then the bottom part,
180 minus 700 is 280.
No, it's 196.
Is it? Yes.
980 minus 7.
Why 784?
28.
It's good.
oh, in this case, then you get that. Are you getting that?
Why is it 700? Why, what's the 700?
980 minus 784. Value of A
So B is, what's the value of B?
what's the value of B?
1.
1. Are you getting 1?
Yeah, I got it now.
Okay. Then A, sum of y minus b, sum of x over n. What's the value for sum of y is 81. The value of b is 1. The value of sum of x is 28
Over 7.
over 7. So you get 81 minus 28
53.
over 7.
It's 53 over 7.
Which gives you what? Gives you? Sorry?
So it's 53 over 7, which equals to 7.57.
7.57. Okay. So what is our equation? Y is equal to a plus bx. A plus bx. Our a is 7.57. Our b is 1. Right. So what then does it do? We are looking for observation number 8.
8.57.
So we are looking for observation number 8. So it will mean, can I take this out? Y is equal to 7.57 plus bx. Now in terms of this first one, this one, what are we looking for? We are looking for that value, which is the 8th period. Right? So we come and substitute it. So 7.57 plus b is 1 times 8. 7.57 plus 8. And what do we get?
15.57.
15.57.
0.56.
So what are we saying there? We're saying, so this is our demand for October to December.
It's not 15, it's 60.
It's 16.
Oh. Okay,
So this is our value for the 8th quarter, the 4th quarter of 2018. Okay. First method. So this is the first method. Practice? Practice question? Okay. 2018. What are we looking for now? What shall we call this? June, July to September, then October to December. So what shall we call this? Okay. What numbers shall we use?
Let's use our
12.
This is now a question now for you to do just now. So I'll put here that and say, oh,
78, 140, 160.
the students doing the BCom at the beginning of the year, we had 30. And then we get, with how many in April?
25.
The third time we had
9.
9.
20.
Hey, our student numbers are increasing.
Oh, you wanted to increase? 30, 25.
So what happened here? Okay, let's make this 20, right? 30, 20, 40. So what is the value there?
That's what he's been given.
The question. What's the answer?
What did you get to 35?
Oh, yeah. It's not difficult, yeah?
6 times.
It's only when you're looking at. Brandon, are you coming
6
all right?
times 90 is...
What answer are we getting?
42.
40. I got 70.
Yeah,
42 because you used
A 5.
a 5 here. 25. Yeah, so 42 would be correct. Okay? 42 would be correct.
Well,
The rest? 40. Are you getting the 40?
Yeah, finally.
You are getting the 40.
Yeah.
Okay. So it means our intake is not increasing.
Your presumed
40.
intake. Assumed intake.
It's not increasing.
Or mathematically calculated future intake.
Okay. Somebody to take us through the workings so that we can all be brought up to speed.
Okay.
I'm going to try.
Bianca?
Or Pierre.
No, let's.
Bianca.
Okay. Bianca, give it a try.
Oh, go Bianca.
Yes, I shall.
Give it a try.
Bianca in the house. Oh, definitely.
What's happening now? We're going to Pierre.
Yeah. Yes.
Eh?
You miss it.
No.
Oh.
Bianca.
with the values for x equal y. The sum of y is 90, the sum of x is 6, the sum of xy comes to 190, and for x squared to 40. The amount of
In
And number of
Observation.
observations.
number of observations. There we go. So first we calculate b.
What is B?
in a some
b is exactly that, b. Second letter of the alphabet.
Yeah.
That's what it is.
This question 2, eh?
yeah.
See?
Sorry.
Question 2, eh?
So we've got 3 observations and the sum of xy being 190 is sum of x times sum of y. Times speed. So B comes to the total of and A is calculated at 20, which means, alright. We calculated A to be 20 and that we add 20. 20. And that was calculated based on
Now the question is, can you explain to colleagues, how do you get that 4? The
That's
4
the
there,
Fourth
that
observation
Oh,
is
yes.
missing.
So we're looking for the fourth observation. So assuming they're going based on that, the 4 over there.
Gotcha.
Are we all right there?
Awesome.
I got it.
Okay. Now let's look on page 103, where it says interpretation of the trend line. Can somebody just read out those points with bullets?
The trend line is a free of 103. What's this? Statistical, seasonal, and irregular influences. These other influences have been removed by trend analysis, leaving only the trend influence. The strength of the trend influence, growth or decline, can be gauged by the magnitude of the slope coefficient. B, a strong upward or downward trend, is shown by large positive or negative values of B, which, while values of B close to 0 indicate no strong upward downward pressure on the values of the time series due to trend forces.
Okay, just stop there.
Sorry, what?
Yeah. That's what I thought.
What is it?
Now, what is our equation here? y is equal to 20 plus 5x. Is that so? That is our equation. Huh? Yeah. So using our equation, what values of x are we, what values of y are we getting? When x is 1, when x is 2, 3, 4. So we are getting here 25. We are getting here what?
5 times 2, 10, 30.
And then here, what are we getting?
35, 35,
And then here,
40.
40. Okay. Now compare with the original values that we have. What did we have as the first observation? We had a question mark there.
30, 20, and 40.
30,
25.
20,
40.
and 40. Okay. So if we're talking about bread, or I'm using bread too much as an example. So if you look now at the values, right? An element of seasonality has been removed from these values. So now we can actually see the trend of what is happening without the impacts of the season. So when we plot this, right? When we plot this and have time on the other side, 1, 2, 3, 2, 3, 4. We will say 1 is moving with 25, 2 with 30, 3, 35, and 4 with 40, somewhere there. So it's a 10, 20, 30, 40. So what do we get? We're getting a trend line. What is it showing? It's showing that it is going up without the element of the fluctuations in the season. That has been removed. So we are able now to use that information to make decisions without the impact of changes in cycles, changes in the seasons, but just what is happening. So you might look at this in terms of at micro level, in terms of the demand, and say, what is the trend here? What is the trend with respect to the demand of our product? Let us remove the issue of seasons. Let us remove the issue of different cycles and just look at the trend out there. In general, is it up or is it down? Okay. Now any questions there? Now let's look at the second method. The second method is, let me refer you to page 102. Shall we use that same example? Which one? That one. We had 7 observations.
Yeah, let's use that one.
We had that same observations. Okay. So let's use that same one, that one. The second method, which works on the sum of x being equal to 0. Okay. What do we mean, the sum of x being equal to 0? Let's have our y. Our y, we had 7 observations. Huh?
Yeah, y was
8,
81.
and then we had 6. We had 13,
13, 16, 14, 9, 15,
14,
9
9,
and
and
15.
15. Right. Now we need x. What do we have here? How many observations do we have?
7.
Is that an odd number or an even number?
Odd.
Odd. Okay. On page 101, it says, you say n minus 1 divided by 2. So there is a minus before. Okay. See, there is a minus before. So you say minus, and then n minus 1 divided by 2. Okay. See that?
Yeah.
So what is the value of n here? We said it was 7 there. So we would say 7 minus 1 over 2. 7 minus 1 is 6. Divided by 2 gives you 3. Oh, don't forget the minus. So it's minus 3. Right? So it works on having the sum of x being equal to 0. So now you say your first observation of x then is minus 3. Right? Then your next observation, you add 1. So you say minus 3 plus 1 gives you
Minus
Minus
2.
2.
minus 2 plus 1
Minus 1.
plus 1
0.
plus 1
1,
plus 1
2,
plus 1
3.
3. So that's what it means when it says sum of x using the method sum of x is equal to 0. So this method now makes the sum of x being equal to 0. Just add these totals and see what you get. What do you get?
0.
0.
0. So the sum of x is equal to 0. Now then, using this method then, because the sum of x is 0, the way of finding b then changes. It becomes sum of xy over sum of x squared. Sum of xy over the sum of x squared. So here you would go on now and find xy, x squared. Okay. So what would be xy here? Minus 24. And here,
Plus 12.
minus 12. Here,
Minus 13.
here,
0. 14. 18. 45.
then what's the sum of xy? The total there. Sum of xy. What's the sum of xy? You add 1 to... What's the sum of xy?
28.
28.